This is Madhumathi, Assistant Professor, Department of Food Technology, SNS College of Technology. So in this video, let's see about the properties of the fluids. So we all may wonder what are all the different types and the classification of fluids. So let's have a look into it. There are 5 types of fluid that we'll see in this video. First one, basically it is called as ideal fluid, and second real fluid, third Newtonical fluid, non-Newtonian fluid, and the ideal plastic fluid. So coming into the ideal fluid. So what do you mean by ideal fluid is nothing but the fluid that is incompressed and have no viscosity falls in the category of ideal fluid. So it is not found in actual practice, but it is like an imaginary fluid because all the fluid that exists in the surroundings have some viscosity and there is no ideal fluid in reality. So this we call it as the ideal fluid. And what we mean by the real fluid is real fluid, that which has at least some viscosity, we call it as the real fluid. Actually all the fluids that are existing or present in the environment itself, we call it as the real fluids only. So next one is the Newtonian fluid. So Newtonian fluid, it is nothing but if a real fluid that which obeys a Newton's law of viscosity, that is when the shear stress is directly proportional to the shear strain, then we call it as the Newtonian fluid. Example, we can state water and kerosene as the example for this. And non-Newtonian fluid is nothing but this is the opposite of it, that which does not obey the Newton law of viscosity. Example, paint, toothpaste. And coming to the picture where ideal plastic fluid is given, that is based on this we can differentiate which is an ideal fluid, ideal plastic, Newtonian, and the non-Newtonian fluid. So when we plot a graph in between the velocity gradient and the shear stress, so the fluid that will have the value of the shear stress more than the yield value, and when the shear stress is proportional to the shear strain, we call it as the ideal plastic fluid as given in the diagram. And next one, let's see what is about viscosity. So viscosity is nothing but a property that we denote for the fluids that is closely related to the resistance to flow, and mainly it is defined in terms of the force that is required to move one plane surface continuously past another under specific steady state conditions when they are between and is filled by the liquid in question. So it is also in other terms it is defined as the shear stress divided by the rate of the shear strain. So this we call it as the viscosity. It is mainly resistance to the flow. So in viscosity itself we can categorize into two types. One is the dynamic viscosity, another one is the kinematic viscosity. So dynamic viscosity is defined as the shear stress required causing unit mass of shear deformation. So we can denote in formula mu is equal to tau divided by du by dy. Its unit of dynamic viscosity is Newton per square meter square. Newton per meter square is the unit, or kg per meter square, or we can denote it as poise. Kinematic viscosity we denote as V. Dynamic viscosity, as I told, we denote in the letter mu, we pronounce. So kinematic viscosity is nothing but the ratio of dynamic viscosity to the mass density. Its unit is meter square per second, or it is denoted as a Stoke. So next is the vaporization. So vaporization we all know when the change from a liquid state to the gaseous state is called as the vaporization. So in this picture we can clearly see there is a liquid below where like after some time it is actually evaporating in the form of gas. So that phase is called as the vapor pressure. Due to vapor pressures is being created at the top, and it releases as the gas. That phase is called as the vaporization. Next is the, what do you mean by the vapor pressure? So the vapor pressure is nothing but when the liquid is kept in closed vessel, the vaporization will takes place. That is, the molecules will escape from the free surface of the liquid, and this vapor molecules will occupy the space between the free between the free liquid surface and at the top of the vessel. So these will get accumulated vapors will exert a pressure on the liquid surface. This pressure is called as the vapor pressure of the liquid, and this vapor pressure is like that maintained here is 2337 Newton per meter square at 20 degrees Celsius, but 1 lakh 1325 Newton per meter square at 100 degrees Celsius. Next to the surface tension. So what do you mean by surface tension? Is nothing but it is defined as the tensile force acting on the surface of a liquid that is in contact with either a gas or on the surface between the two immiscible liquid. Immiscible means those two that does not dissolve each other. So such that the contact surfaces will behave like a membrane under tension. So that point we call it as a surface tension, that as a tensile force that which acts on the surface of the liquid. So due to this, the molecules will get attracted and the liquids will have properties of cohesion and adhesion. So this we call it as the surface tension. And next, cohesion is mainly due to the force of attraction between the molecule of the same liquid. So when we consider a liquid, there will be molecules present obviously. So when due to the force of attraction in between the molecules that is present in the liquid, the cohesion will take place. This force is very small, and addition is done due to the force of attraction between the molecules of two different liquid. So when the molecules attract between the same liquid, we call it as a cohesion. When there is a force of attraction between the molecules of two different liquid, we call it as a addition. The molecules of the liquid and the molecules of the solid surfaces. So next, what is compressibility? So it is a important term. So compressibility of any fluid is nothing but the reduction of the volume of the fluid due to an external pressure that is acting on it. So a compressible fluid will reduce change in volume in the presence of external pressure, and it is also a reciprocal of the bulk modulus of elasticity, which is defined as the ratio of the compressive stress to the volumetric strain. Its unit is Newton per meter square, and it is given by 1 by K. In nature, when we see, all the fluids are compressible and the gases are highly compressible, but liquids are not highly compressible. So the relationship between the bulk modulus of velocity, elasticity and the pressure for two different processes are compression are as isothermal process and the isentropic or adiabatic process. So thank you.